Okay, to round out our review of chapter 11, the last big thing I'm going to cover is making ethers. So there are about 5 main ways to make ethers, but most of them are reviewed from what you've learned from chapter 6, 7, 8. There's substitution, elimination, and a little bit about alcohols. Okay, so here we go. Here are the 4 main ways that I think about when I think about how to make ethers. There is an SN2 reaction, which is basically Williamson ether. So you get an ethoxide or a methoxide, whatever, a good nucleophile that will react with the leaving group, kick it out, and make an ether. The next way, this works best with symmetrical because if they're not 2 of the same alcohols, you can get mixed results. But if you do acid catalyzed, then one of the alcohols will become protonated as a good leaving group, and then the other alcohol will attack and kick it out like an SN2 reaction as well. So both of those go to a very similar as an SN2. Now the third one goes as an SN1 reaction, and it basically only works asymmetrical acid catalyzed synthesis of an ether basically only works if you have one tertiary alcohol, because that will get protonated and the leaving group will actually leave, leaving behind a carbocation, and then the other alcohol will attack. So that is more of an SN1 reaction. So these two, SN2, this one is an SN1. The very bottom one is actually an addition reaction. So very similar to when we add hydrogen and alcohol across the double bond, except instead we're adding hydrogen and some kind of OR group. So depending on what you put as your alcohol for the solvent instead of water, you can change that from an addition reaction that adds H and OH to an addition reaction that adds H and OR. Those are the main ways to make ethers that you've seen before. There is one way to make an ether that's different that you find out in this chapter. That's actually how to make a special type of ether, which is an epoxide. So if you look here, you have a double bond and you react it with what's known as a peroxy acid. So sometimes this will say MCPBA, sometimes it looks like this with 3 oxygens, a carboxylic acid basically with an extra oxygen. It's called a peroxy acid, and that will make this special kind of ether known as an epoxide. And you can see the biggest thing is when you see this, it'll make an epoxide, and this is a trans bond, and so your groups are trans as well in the final product. It's also important for you to know how to open epoxides. It goes basically by an SN1 or SN2 like mechanism as well, and I have an extensive video about that on my YouTube. If you need to check it out, you can go to my profile, and there's like a little square with the YouTube, and you can click on that and I'll take you straight to my videos. I hope that's helpful for you. If you have any other questions about chapter 11 or anything else I can review to make your life easier, just let me know. I love to help.